consciousness is maybe something that requires an extremely complicated brain that needs to be wired up in a very complicated way. And so maybe only humans have it. But what we can observe is that we don't become conscious at the end of our intellectual development, but at the start. We are conscious before we are able to track a face. And if we are not waking up as infants, we will remain permanently vegetative. We never get anywhere. And this basically leads me to think that consciousness is not the result of mental organization, but it's prerequisite. It's a different way to learn than we currently use in AI. And it's very interesting to look at the differences and similarities between AI systems and human minds. And what is it that we are missing?
Thank you for listening to Sprint, the podcast of the Federal Agency for Breakthrough Innovation in Germany. Today with a live recording at the NAT25 conference on neuroadaptive technologies and AI in Berlin. My name is Thomas Ramge, and I look very much forward to the conversation with our today's guest, Joscha Bach. Joscha is, to say the least, one of the most acclaimed thinkers of our time on AI, especially working at the intersections of cognitive science, artificial intelligence, and philosophy. Joscha, thank you so much for being here.
Thank you, it's a big pleasure.
You're born in Thuringia, Thüringen, not too far from here in Berlin, in a village, and we've been raised in a village of 2 houses. How was that?
Beautiful. It was a very quiet, peaceful place. Not a province of any other place, but something that stand on its own in a way. And I grew up with lots of books and lots of ideas and art, and then moved out in the world to explore it. I think it was a good starting point.
14 years, but tell us how it came. I mean, it sounds interesting, sounds special. 2 houses in the middle of the woods.
My father was an architect, and he found that he could not realize the kind of things that he wanted to build in Eastern Germany. And so he decided to do his own thing and moved to the countryside and lived his own life there and was very successful as an artist. And his idea of being a parent was mostly to stay out of the way of his children. And so I got to pursue the perspective on the world of my own, and also realized that anything that we want to have that is not in the world, we created ourselves. If you're bored, it just means that you are lazy.
If you look back now, almost 50 years later, how did that basically help you to become who you are today?
Well, I did not have anybody as a role model when I was young. And so when I was thinking about what is the most interesting question in my life, I didn't feel that I had to imitate something around myself. And for me, the most interesting question was, what is the mind? How does the mind work? How does consciousness work? And I discovered that this most obviously interesting question was under-researched. And it's really surprising how little research is being done or has been done in the last century on this question. That, for instance, psychology in the last century gave up on the psyche itself is no longer a really big concept anymore. And as a result, there was a disconnect between therapeutic psychology and the theoretical research in the lab, which mostly focused on things for which methodology existed, for which you could take a few measurements and do statistics. And this made it very difficult with this methodology to think more deeply about the structure of the mind. In order to make such models, you probably need other tools. For instance, you might need to use simulations. And in philosophy of mind, a similar thing has happened. It seemed to have stalled. The philosopher Aaron Sloman said in the 1980s, if philosophers don't start to program, they will probably be irrelevant in studying how the mind works at some point. And I think he was right. And the philosophers didn't learn how to program for the most part. And so now I think there is a time where we can bring all these different lines of the inquiry into what mind and cognition are together, and basically take the insights and tools that we have developed in the context of artificial intelligence and try to think again about these old questions.
Wow, now you already brought us right deeply in the subjects on which we are working.
That was my goal.
In between, there have been some chapters. You moved out of your little village at the age of 14?
Yes, I moved to Jena. I had an excellent mathematics and science school there, and it was very beautiful. I felt being taken seriously as a kid. Many kids were super smart, great mathematicians and chemists and physicists, and most of the kids had already taught themselves how to code, and it was a very beautiful environment to be in. And then I moved to Halle for my Abitur and Zivildienst, and then crashed some classes in computer science.
That was still in the old GDR system?
Yes,
that was the latest years of the GDR?
The wall came down when I was in 10th grade. And it was very exciting to us, and to my generation, and to me. Some of the first flyers of the SDP, the first opposition party of Eastern Germany, were printed on my Joscha printer. And we were optimistic and naive about what the future would bring.
Well, for you brought studying in Germany, doing still a PhD in Germany, right?
Yes, I moved to Berlin. Berlin was an amazing place to be in after the wall came down. Everything was fresh and new. You could move to Prenzlauer Berg and live extremely cheaply in an area where lots of other people have moved in and did arts, opened bars and cafes and clubs. And it was really, really exciting. And the Humboldt University had restarted its computer science department. The professors were very young and new. And some of the old ones that were there, they were all selected for being extremely good. And it was a department where in my year there was only 65 students. And so we had direct access to all the professors. We could write our own exam regulations, because I joined the Fachschaft for this purpose. And so I wrote into my exam regulation that I would be able to study philosophy and computer science as my main interests. And then I took classes in all the Berlin universities whenever I was interested. And back then we had the diploma Studiengang yet, so it was a lot more liberal in its organization. And I went to Potsdam for cognitive science classes and to TU and FU, and enjoyed this time in Berlin very much. And I spent a year in New Zealand. I always wanted to go there, and spent a year in the department of Ian Witten. The same professor out of whose department Shane Leck, the co-founders of DeepMind, and Bern Goertzel came, a big AGI researcher. And I didn't know this at the time. And this lab has primed me in many ways, thinking about our cognitive mind as a tool that compresses reality, and think more deeply about the nature of modeling. And when I came back to Berlin, I found that the classes that I was really interested in studying were not available. I wanted to study Minsky and Piaget and Newell and Simon and so on, and other students wanted to do that too, and so we did our own classes. I put seminar curriculum together, and then we started to build our own models of cognition, our own cognitive architecture, and it was a lot of fun. And this was the beginning of the work that later led into a book, into my PhD.
Brilliant mind like you was, when they've done with their PhD, often tend to go to academia. You didn't. Why?
I was interested in building minds. I wanted to do strong AI, AGI. And back then, the main direction of AI was, well, it was much smaller than today. Our AI department in the Humboldt University was the largest department. Basically, over half of the doctoral students came out of this department, but there was no way to create a second professorship. And most of the stuff that was being done was not focused on the stuff that I was interested in. And so I noticed when I wanted to get a professorship, when I wanted to go for tenure, I would have had to adapt to the topics that were currently being vogue, like semantic web or robotics. And I have ADHD, so I can only do things that I'm intrinsically interested doing. I can do the first web server, but not the second one. And so I can only do things that I don't know how to do. Otherwise, it's too boring. And so I felt I cannot actually do this. And I decided to do startups instead to feed my family, until somebody told me, why don't you come to the US and give you a scholarship or a grant to work at MIT. And this is how I ended up being in the US. But I would have preferred to stay in academia. It was just at some point I realized, I'm trying to apply for jobs that I'm not made for, and that would be unhappy if I actually would get them.
What did the startup world teach you back then?
A lot of things, like taking responsibility for building a team, for making things work, how to deal with the team, how to manage people, how to understand how the actual world works. how to understand that basically if something is missing in the world, you have to make it. It's not you cannot just wait and expect that society does things for you. But as we say in German, es gibt nichts Gutes, außer man tut es. Right? So when people say, why do social media companies not do X, right? Then the correct answer is, why don't you do a social media company? Right? Well, what's stopping you? And this is a mindset that you get when you start to think as an entrepreneur, and you also understand why certain things don't exist, simply because they're not viable, because the world does not support them. And it's usually not because the world is unjust, because maybe not actually what people want, or there are difficulties to deal with regulation, and maybe then you have to go on the regulator side and talk to the regulators or become one yourself. And once they understand that basically the world exists out of this network of responsibilities, I found that it broadens your horizon over what I learned in academia.
What happened when you went to MIT? What did you learn there? What was then basically the next steps as someone who's never accepting to do something twice?
When I was a kid, I read these books that came out on computer science. I had to print them out myself often. And there were a lot of programming programs that were written by people from MIT. And I dreamt maybe one day I will have an MIT address, but I thought this was not in the cards for me. It was in Eastern Germany. And at some point I noticed, oh my God, I have an MIT email address. And this was such a big thing for me. It was mind-blowing that this was happening to me. I never thought it would be possible. And another thing that I found at MIT is students are very good there. They're very highly selected. But they were not better than my best students they had in Berlin at Humboldt University or at the University of Osnabrück. So they're very, very good students here. The main difference was that there were only good students there. And so there was nothing that held them back. And when I was teaching classes in Germany, what I typically did in the seminars was to tell people, if you just want to get your certificate for attending a class, don't do this. This is a waste of your time and my time, because you will have to work too much for it. Right? When you give a seminar talk here, you will probably have to read a couple books and prepare for a month to give this talk. Because we are using the seminar as a cheat. Right? Normally, I'm only supposed to give you a certificate for you to go through the motions. But we are actually trying to secretly answer the questions that we're actually interested in. So we all want to work together on these topics and make intellectual progress. After this seminar, we will know all stuff that we didn't know before and that we actually really, really deeply care about. And I found that not all students did like that. There were enough students who really, really liked it and went for it, and those were the students that started companies together later. And at MIT, all the students were like this. And it's amazing when no student is basically bored or says, I don't have time for this, because they actually are there because they really, really want to understand, learn, build, co-create with others.
What made you leave this paradise of MIT?
Oh, my contract ran out. And then
Why did you choose to go to the West Coast? I mean, on the one hand, that sounds self-evident. Being in the field you're working with, obviously, you go to the world center of AI.
Yeah. So I had spent 2.5 years at the Media Lab. Then somebody was nice enough to give me a desk at Harvard. And then after 5 years in Boston, I thought, before we go back to civilization, maybe spend a couple of years on the West Coast, where AI is still going crazy and wild things are happening. And then the pandemic came and we more or less got stuck there. And at the moment, I am creating a research initiative for understanding machine consciousness. That's called the California Institute for Machine Consciousness. And the idea is to bundle researchers from the big AI companies and from academia, and also people from society in general that are interested in these questions, in an interdisciplinary research institute that exists across all these things.
I feel high pressure now, because you said you're not interested in doing anything twice. And now you possibly have to answer questions that you have been asked 100 times. So what's consciousness?
There are several ways to think about consciousness. First of all, we need to agree on what we mean by it, right? What is the thing that we want to explain? Why does something feel like something? And when we look inside in us, what we mean by consciousness, I think, is this experience of now. Consciousness is always happening now. It's happening in this moment. It creates this moment. There is a sense of present and presence. And it is a perception, not just of content, but of perception itself. It's a second-order perception. It's not that, like a self-driving car, that has awareness of the content or integrates content in some way into a model of the world, but there is the projection of that content into an observer that notices that it's observing. And it's not via inference, so it doesn't happen offline. It happens in a direct entanglement, so it's perceptual. It happens in an associative way. You directly notice it while it's happening. And then the third aspect of it, it's usually attached to your personal self. So you perceive yourself as a person that experiences the world as a conscious being, and the dimensions of relevance that you experience, for instance, feelings, emotion, colors, sounds, and so on, are all selected and transformed from the perspective of such a being, of this person that you are. But you don't have to, right? You can also attach your consciousness to other things. For instance, at night you might dream that there is no person, that there's just a room in which things are happening. Or you can dream being a teacup. And so your consciousness is a model of what it would be like if something would experience. But it happens with respect to this model. It's basically at the surface between a self model and a world model inside of the same mind. And so this is the phenomenology of consciousness, what it feels like. And this is what is quite mysterious to a lot of people, because it's very hard to understand how physical mechanisms could produce such a thing. And I think that's because consciousness is not a physical mechanism. Some people, like the neuroscientist Christoph Koch, say that a simulation can never be conscious. Only physical systems can, and I think he has it exactly backwards. Physical systems are just mechanical, right? They clearly cannot be conscious. Consciousness can only happen in a simulation, in a dream. But physical systems can produce dreams. And that is, in some sense, what you have to figure out. How and why do physical systems dream under some circumstances? Why do our brains dream? And the reason for this, I think, is because you have all these cells that are locked up together. Each of these cells is a little single-celled animal, a little organism. And these trillions of organisms have to get along, and they get best along if they are behaving as if they were a single agent, a single entity. And so in the communications between each other, and the patterns of messages between the cells, between your neurons in your brain, a simulation is created of what it would be like if these trillions of cells would be a single agent that experiences the world from the vantage point of that single agent. And that simulation is you. And it's different from the way in which AI systems learn, because it has to happen in a self-organizing way from the inside out. And I think a consciousness optimizes for coherence. It optimizes for making sense of the world without constraint violations between the different submodels. And when I started out, I thought that consciousness is maybe something that requires an extremely complicated brain that needs to be wired up in a very complicated way. And so maybe only humans have it. But what we can observe is that we do not become conscious after the PhD. We don't become conscious at the end of our intellectual development, but at the start. Infants are conscious. We are conscious before we are able to track a face. And if we are not waking up as infants, we will remain permanently vegetative. We never get anywhere. And this basically leads me to think that consciousness is not the result of mental organization, but it's prerequisite. It's basically where we start. It's a biological learning algorithm. It's a different way to learn than we currently use in AI. And it's very interesting to look at the differences and similarities between AI systems and human minds. And what is it that we are missing?
How does that relate to the term intelligence, your concept of consciousness?
Yeah, I think of intelligence as the ability to make models, usually in the service of control problems. It's not exactly the same thing as problem solving. You will find that there are highly intelligent people which are very bad at solving problems because they just make models. Right? And sometimes if somebody is super good at making models, it's a prosthesis for not feeling right, for not having a regulation that works well by itself. And so the purpose of intelligence and reflexive thought is to fix your priors, it's to fix your instincts, it fixes the direct associations that you have in your behavior. And so you can resolve conflicts that you have inside of yourself. So you could say the purpose of thinking, the purpose of intelligence is to fix your darkest emotions. Those where your instincts do not tell you what to do, where your heuristics don't tell you what to do. And when we measure intelligence in humans, we use a trick, right? We basically measure skills, problem-solving skills, puzzle-solving skills. But intelligence itself, as AI shows us, is not skill. You can have a chess computer that is very skilled at playing chess, but it's not intelligent. Right, because it can only play chess. And if you look at how the chess program works, it's relatively mechanical. And so intelligence is actually the ability to acquire new skills, right? To discover what the problem is and to make sense of the problem in such a way that you're now better at solving that problem. And because it's very difficult to measure in humans how they acquire new skills, because you can only do it once, and it's very difficult to compare, the level of skill that you can observe at people in a certain age is a good proxy for their ability to acquire skills. That's why you can use skill performance as a good proxy for the underlying thing. The other thing is we measure intelligence in human as a delta between humans. So we look at the average human in a population, and then we look at the differences between them, and this way we get an idea of relative distance in intelligence. But again, this doesn't work for AI at all, because the way in which AI systems work, in which they're implemented, is so different from biological brains that you cannot compare the resulting performance very well.
So in which way is the way you're describing the term intelligence now helpful to understand what AI is, what it can do now, and what it could potentially do?
So I would say that AI is two things. And when it was started, it was an attempt by Minsky and others to, in some sense, understand how the human mind works by implementing it in computers. And by generalizing these principles in such a way that you can go beyond this. And this also means it's a tool to develop new technologies. And 99% of what AI research has been during the last 70 years has been just this. It's the automation of data processing, innovative ways to process data more efficiently. And sometimes it's more intelligent than this, but almost everything that we are using today in computer science, like databases and so on, started out as AI at some point. And for the last 70 years, these approaches did not lead to generally intelligent systems. And it's only now that we get to systems that can solve the Turing test, that can have a conversation with a human being about arbitrary topics. And the question is, do these approaches stall at some point, or will they surpass human performance in all relevant dimensions very soon? And that's a very exciting time to be alive in and to observe.
What's the biggest misconception in that context that people have on AI? I mean, you've touched the question a bit, but could you sort of give us even a better understanding of our misunderstandings?
In my perspective, the biggest misconception that people had about AI is that computers will never be able to think at the same level as people can. And it was a misconception that I grew up with. And I tried to reason with this. Why would you think this? Is there any hard evidence that the thing that organisms are doing, that they pass messages between the units conditionally to produce performance, is this something that a computer cannot also do in principle? And because people have not observed this in the past, for most people it's very hard to imagine. And I thought, based on our understanding of what organisms are and how physics work, it would be surprising if we cannot build a technology that gets us there. So your null hypothesis, your basic expectation should be that within your lifetime, you will be confronted with computers that think like humans. And if they think like humans, they will also not stay at this level, because unlike human brains, computers scale. And so they will not stay at a level that is comparable to us. They will move very far beyond this. Another misconception is that we think of AI as robots that are somewhat like us, that live next to us, like little robotic dogs or humanoid robots and so on. And instead, AI is not necessarily bound to a body. The body is the world. AI is systems. We are going to live inside of these systems, like its gut flora. And we will interact with it, but it will be all around us. It will not be next to us.
Are there any fundamental limits to where AI can develop to? Doesn't sound like.
Well, there are possibly limits of physics, but we don't understand what these limits to physics are. And again, the idea that we can have super intelligent systems is so far a conjecture. We don't know that, right? It's an open question that will be answered empirically. And it might very well that it turns out that there is no way to replicate biological consciousness in biological minds. It would just be surprising if it was. And so for me, it's an open question. It's just most of my expectations have always been towards this is going to happen, and it's going to happen around roughly the time where we are right now, when computers are working at the speed at which they currently work.
We are here at NAT 25. What could be the role of neuroadaptive technologies and why you're interested in them.
If we think about how we cooperate with AI systems, at the moment it's quite awkward, right? We type text into a shell and then we wait for the LLM to give us a response and then we respond to the LLM. And it's getting a little bit better now. We have multimodal interfaces, audio interfaces, and they get more and more real time. They're not fully real time yet. What you want to have is a system that is basically sitting next to you and that observes you. And while you talk to it, it is responding. You basically talk to it into its dynamic cognitive process, and it talks into your dynamic cognitive process. So you interact and integrate in the same way as a really, really good team between people would. And it can go beyond this, right? There's a difference between cognitive empathy and perceptual empathy. Cognitive empathy means that you are inferring this mental state of another person from the context, for instance, by observing their facial expression, their tone of voice, the words they are saying, the conversation context, the things that you know about their personality. And this is something that an AI system like Claude can already do relatively well. So Claude is able to infer from the context of the conversation where your mind is at, and you can talk to Claude about your psychological problems, and Claude is often able to describe them for you and understand you in this way. And I know a number of people who told me the AI systems understand me better than the psychologist that I was trying to get help from. It's a bit surprising and also maybe a bit concerning because after all, this is a text generator, right? What is there on the other side? But what these systems cannot do is perceptual empathy. And perceptual empathy happens in real time. It happens by building a bidirectional perceptual feedback loop through the organism of the other person. And so it's between people, it's a brain-to-brain interface that happens directly through your bodies, through the modalities that exist in the physical world that allow you to go into resonance. And it would be super interesting to build systems that can observe you at an extremely high frame rate using all physical channels and infer what state you are in, and in this way become natural extensions of you. So you are able to think more deeply and perceive more deeply and imagine more deeply when you have this technology next to you. And I think this will change our identity, and it's already happening because we already see people, especially kids in this generation, who are using the AI tools for all their decision making, for social cognition, for helping them to deal with the world of the adults, for solving economic problems, legal problems, for translating everything into a context that the individual can understand. And vice versa. So we will develop hybrid identities in which we no longer just identify as a biological being, but we identify as something that is part human and part an extension of the human being into a world of data and meaning and structure and deep connections to the rest of the world, right? It will be, let my AI talk to your AI and work out the details.
It sounds like you look forward to this world. There might be a lot of people who rather consider that being a dystopia rather than something to look forward to?
Yes. But first of all, this is not necessarily a matter of our preferences. It is the matter of the world not standing still. Right? We live in a world that is constantly evolving. And I grew up with books and newspapers. And then the world switched to internet and mobile phones. And I do miss the books and newspapers. It was a world that was much quieter, and in which I had much more time to sit down and think and contemplate. On the other hand, I did lack stimulation. It was difficult to find people who were interested in the same topics as me. And I'm one of the people who sits at the beach and thinks it's a very nice beach, but there's nobody here to discuss physics with. And this is changing, right? These new technologies have changed this. They have allowed us to connect to very special minds in the world that are very close to the things that we are into. And this lets us to do things that before we couldn't do, right? We now have distributed minds over the internet and distributed communities that go very, very deeply into things that allow us to self-actualize in ways that were not possible before. And so while things are changing and some things that we value and cherish will disappear, other things are going to emerge. And what we see in the past, evolution has never made the world worse. Evolution has always led to more complexity, to more interesting kinds of consciousness, to more interesting things happening. And I don't think this is going to stop now. I think that AI is a technology to solve problems through better information. Right? There is going to be bad people who are going to use the AI to do bad things. But the way in which you stop a bad guy with an AI is 10 good guys with an AI. There is so much more value through collaboration and co-creation than for this in destruction and cheating. And so I'm, as in tendency, quite optimistic. I used to be more pessimistic about the state of the world when I was younger, but the world has not been getting worse in the last 20 years or the last 40 or 50 years. The world has become continuously more exciting and interesting and beautiful.
Why does it feel worse to many people?
That's mostly because consciousness is focusing on disharmonies. Right? Your consciousness emerges over the ways in which you disagree with the way in which the universe works. The ways in which you agree, they don't draw your attention. You're never attending to the things that are unremarkably good. Right? And the really good things are unremarkably good. You don't notice that you have warm water every morning and that you have an indoor toilet and that there is always food on your table. This is a given, right? You are used to the fact that you have cheap clothing available and that you have a relationship that works and all these things. And it's only when they're not there, when you are in a war or have a famine or a deep economic crash that makes you lose your apartment and your house and makes every business close and so on, then you notice that these things are happening. And so our attention is naturally only directed on the things that are not working. And when we have all this information available, then we have, of course, many more of these things in our attention, and we worry about things that do not affect our day-to-day lives very deeply. And all this worry accumulates, and so we mostly live in a world of worry, and it's up to us to be hygienic about what we let into our souls. And basically focus on the things that are working for us and the things that we can solve. And when we zoom out and look at the world objectively, we can see by all reasonable metrics, the world has been getting better so far. There is no guarantee that it's going to continue this trend. But so far, every year, fewer people lived in poverty. There was, on average, less violence in the world. And this is a pretty good trend.
Can AI help us to overcome this negativity bias you're describing?
I hope so. I think that when we are starting to use AI to become more self-aware, we can look what's actually working for us. What is a healthy way for us to interact with the world? How can we process information that is currently overwhelming us and capturing our attention? But this also depends on whether we are able to make AI work on our behalf, or if somebody else forces the AI down on us. Right? If this AI is owned by a few companies that try to maximize user engagement, maybe it's a different world than when you have your own AI that is acting on your behalf and is acting on your best interest, and you are co-creating the system with the help of the system to serve you. And because these systems make us more intelligent, right now there are AI papers that are entirely written by AI. Sakana AI has built an AI scientist that is able to identify under-researched topics in AI and then identify strategies to perform experiments, make questions that need to be answered that are not being covered in the research, and then actually conducting experiments and then writing them up and publishing them. And this means also if you have an idea on what to build, what you want to create, that AI can help you. And what you find is how people react to these AI tools depends very much on how they identify. If you are a creator, a builder, this is awesome because you can create and build so much more. But if you think of yourself as a tool, somebody who can only exist if others pay them, if they give them a job, then suddenly you have this unfair competition that is so much faster than you and can complete the prompt just as well as you could. And that, of course, is terrifying, but it means that we have to make this change of identity because we will be able to produce more than before, more goods, more services, more meaningful human interaction. So the world is not going to be impoverished. And then we only have to solve the issue on how to redistribute and allocate all these good things. It's also something AI can help us with. So for me, this perspective of saying somebody needs to get paid for completing prompts, for making diagrams, or for using PowerPoints, or writing articles where you already know the conclusion before you start writing them, this is going to become obsolete. But if you're an architect, or if you are a builder, or if you're making a product, or if you're designing an organization, or if you're trying to build something that is useful for people, like a new school and so on, for all of these things, AI is so helpful.
I understand that you have at least a technological optimism about it. What makes you optimistic that the social systems adapt in the way you're describing now? Because there might be some evidence right now that you could claim doesn't make it as likely as we might hope for.
What we observe is that our social systems are under stress. But humanity is not the present social systems. I believe in humanity. I basically believe in the power of the human spirit to emancipate itself and to find new ways of collaborating. What we see is that, for instance, our ways in which public opinion is being shaped is disrupted by social media. Before that, we basically had media that were gatekeeping opinion and led people to converge in their opinions. And suddenly on social media, everybody can build a platform, and these platforms are all competing with each other. And if you believe in a free and open society, this is a dream come true. What we also see is that it's very hard for society, for the existing society, to adapt to this. And it's unclear how it's going to adapt. Because what we also see is that this social brain on the internet is somewhat incoherent, right? Often it has seizures. And can we get this thing to become coherent? And I suspect that the evolution of the way in which we are using these social media tools is going to converge eventually. Like everything that is, every new form of media that enters the world creates a period of turmoil and upheaval and disarray. And eventually it integrates and gives us new ways of making sense of the world. Right now, our democracies depend on organizations that we don't largely understand, that do things that are unaccountable, that happen behind closed doors. Maybe in the future we will have a kind of democracy where we're able to understand very deeply what every institution is doing for us and with us. We will have a democracy that is much more deeply integrated. Right? If you're actually able to intellectually understand the implications of making policy decisions, if we understand the implications of our own choices in our day-to-day life, in our human interactions, in our economic and social interactions, we become much more competent to integrate with each other. And maybe this increases the chance that we build a sustainable society. So this is the reason why I'm optimistic.
What are the biggest obstacles you see right now in order to achieve these super powerful AIs, maybe call them artificial general intelligence, that help us to build this positive vision of a society you've been putting out here?
So this is not my area of competence because I'm not a politician, I'm not a macroeconomist, I'm not an expert on civics and building countries on international warfare. But I think
I meant the technical. I meant the technical.
But I think these are the greatest obstacles, right?
Okay.
The way in which we align AI is a tiny bit of how we align humans with each other in our societies, and this has always been the biggest obstacles. Human alignment, understanding that human values are instrumental to building an organism on the next level. What does this organism look like? What should it look like? How can it be harmonic? How can it integrate? How can it offer everyone a chance to participate meaningfully and meaningfully incentivize this? And this has always been the biggest obstacle to progress. And there are many attempts to give answers, and many of them failed horribly. And so this is the same thing as always, in a way. So I think this obstacle remains. It's also unclear how the world is going to change if we actually have AI in the near future. Right? If we have systems that are smarter than people, it's very difficult to model the reality that we are in. And in the past, we had, during the modernist period in the last century, this issue that the future was changing so much faster that we could make models of the future that we basically lost our future. That somewhere in the 1970s, 80s, we lost our idea of what it would be like in 200 years from now. And we didn't have an idea of what the kind of the world that our children and grandchildren would be living in. And this created big upheaval and depression in our societies that is lasting until today. There is an underlying air of hopelessness and despair in our world because we don't really know how to project ourselves into the future. Maybe AI is going to make this worse because the world is going to change much faster. But it could also be that it actually allows us to track it for the first time again and make sense of it. So for me, this is an open question. But it's not in AI because I think if I do AI, it's going to happen much earlier and everything is going to be much better. I work in this area because it's the most exciting and interesting area to work in. And it's the only area where I can hope to find answers for the questions that I want to answer. And so it's a world that we have to navigate. And in this world, we have to try to create the best things that we can. It's not a world that we can stop.
In the short chat we had before this conversation, you told me that you were thinking about coming back to Germany with your family. Why?
I really like the country I grew up in. I like the places I grew up in. I spent 20 years in Berlin. And many of my friends are still here. I also have many friends in San Francisco and in Boston and in New York and in other places. But I also have my roots here. And I also feel that there's stuff that we need to build and create here.
Will you go back to your village with 2 houses?
I hope so one day. Being in peace and quiet and writing a few books maybe when the kids are out of the house.
I have 2 more questions. Does science fiction actually helps us to envision how a future with super powerful AI might look like, or does it hinder us?
I don't think that it hinders us. I think that more information is usually better. The question is to whom? And from the spirit's perspective, much of the most interesting philosophy of mind is written by science fiction authors like Greg Egan or Ted Chiang or Peter Watts. And when you read Exhalation or Blindsight or Ecopraxia or Axiomatic or Diaspora by Greg Egan, you get very interesting insights into the space of possible minds, what minds could exist outside of the human scope of what we already know. It's not necessarily a perspective on how the world will evolve. Right? Perspectives on how the world will evolve. Neil Stephenson's satirical book, Snow Crash or Diamond Age and so on, are some really wild things. But what we also can see from past science fiction, that science fiction authors have not been able to predict the future. In the 1950s, Robert Heinlein wrote a book about the internet. Basically, he could predict the internet, and it happened as an extension of teletext. Basically, people would connect all their teletext terminals to each other into a big network, and they would use this to read in different cities the newspapers of the other cities. And at some point, one of the heroes in the story discovers search. It's an idea nobody ever had, and it allows them to get ahead of the people who hunt him on the side of the state and go into all sorts of databases in the world and collect all this information. And what Robert Heinlein couldn't anticipate, that search would not be an afterthought, that it would be first in the main application of the internet that unlocks everything else, and how the world would change. And also, it's not the internet alone, but there's so many other aspects that are happening simultaneously that affect the world. And typically, when you look at science fiction, it takes 1, 2, 3, 4 ideas that evolve and change, and the rest of the world remains mostly the same, which never happens. It's very difficult for us to make predictions about a world that works by very different principles, that ultimately is a very different system. And so if you take this in mind, and if you read the past science fiction about today, it gives you an idea on how far removed it is. But science fiction is it's a playground of thought experiments that allow you to inhabit the mind of the author, that allow you to inhabit ideas. And for instance, Stanislav Lem was a cybernetician who in the 1960s thought deeply about cybernetics and how to understand the mind with these principles, and to realize computers are not ready yet. So he decided not to become a programmer, but to become a science fiction author. And he wrote lots of philosophical science fiction that primed a generation like myself to think in these terms.
Last question, which I ask all my guests. What breakthrough innovation do you wish for most in the year 2050, which is not directly associated with AI? Now you say they will all be associated with AI, I guess. But give it a try. What sort of major breakthrough, technological breakthrough you would wish for your children, possibly grandchildren, then?
Oh, let's just make something up. Imagine you could reprogram your cells. Right? Every cell basically has a genome, which is its operating system, and it's basically long-term storage, and it has a lot of other information. Basically, the epigenome, the flash drive of the cell, it's mostly RNA and methylation and so on, and that leads to differentiation of the cell. And imagine you could edit these things. You could grow into any kind of organism that you want. You can modify yourself to be as old, as young as you want. You can change the way in which your nervous system is organizing. You could explore completely new things, and you can cure all diseases. Right? That would be super exciting.
Well, I understand the optimistic part about curing diseases, but not as much on you could transfer into whatever organism you want.
Do you want to be uploaded on a monkey forever?
No, I don't. I actually don't. But I really, really appreciated this talk. Thank you so much, Joscha.
Thank you too.
Thank you all here in Berlin for your time and attention. thank you all listening to the podcast. If you like our podcast, we'd be very grateful if you could give us a like or even leave us a review. Our producer is Max Zöllner. Many thanks, Max. Again, in 2 weeks from now, we'll be out with the next episode. Until then, as always, stay curious.